just containerized a web server. Pretty sweet, yeah? We had our code, threw in a Docker file, mixed in a bit of Docker image build magic, and out popped an image. Well, let's do away with some of the mystery. First up, right, there is absolutely nothing magical about a Docker file. It's just a text file with a bunch of instructions. Alright, it's got a few quirks, like you need to name it with a capital D and it's Docker file all one word, but inside it's just a bunch of really simple text instructions. Then Docker image build comes along, reads it in order, one line at a time, starting from the top. Proper simple. But as well as that, it's going to be read by the ops team, by your fellow developers, by new hires. Pretty much everyone is going to look to this to understand your app. Anyway, each line in the file is an instruction, and you don't have to, but it is convention to write them as uppercase. Just the instruction name though, the contents of the instruction you can totally write lowercase. Anyway, every Docker file starts with a from instruction. This is what starts the ball rolling. It pulls down the base image that everything else will build on top of. And following our best practices, if we can use an official image and a small one, you know what? We probably should. Well, we've gone Alpine, and because we've not put a tag on, we'll get latest. Now, if you're doing this in production, right, you really want to get specific with tags. But you know what? The from instruction will go away and pull whatever image you specify from Docker Hub. Cool. Well, that is layer 1. Next, we're adding a label to set the maintainer. And like I said before, honestly, I am not going to be maintaining this. I mean, it'll always be around for you if you're following along and the likes, but I've zero intentions of patching it and keeping it up to date. I'm really just showing you this so you can see how to use labels, which are great for adding custom metadata. Run here and here are actually how we execute commands and stuff inside the image. We're running some package installs here and installing dependencies here. So another couple of layers there, right? Well, copy here is how we pull files and the likes into the image, and you probably guessed it, more content means more layers. And then we've got workdir, expose, and entry point all adding metadata. Beautiful. But there's still a few gaps, I think. First up, I think I've mentioned the build context at least a couple of times. Well, all it is the location of your source code. For us, right, it's been the working directory. So I've got my shell sitting in a folder called psweb here, and that has got all of my source code in it. That way, when I run the Docker image build, I can just say dot at the end to use the current directory. If my shell was somewhere else in the file system, that's still cool, right? I'd just have to spell out exactly where the build context was. So yeah, build context, that's where your code is. And you can nest stuff as well, right? Because it gets read recursively. So subfolders are fair game, which you need to be careful about actually. Because when you do the build, everything in your build context gets sent to the daemon. And if you've got like a ton of stuff in subfolders that you don't need, you're going to waste resources, especially if your daemon's across the network somewhere. So yeah, only have the code that you need in your build context. And feel free to throw your Docker file in there as well. We did. But when you type Docker image build, whatever's in there gets sent to the daemon and processed as part of the build. Now for us, the client and daemon are on the same host, but it is totally possible to have clients talking to remote daemons over the network. Which brings me to probably our last thing actually. Your build context can absolutely be a remote Git repo. In fact, let's do that. So we've got nothing on this host right now. No images, and then, well, obviously no containers. And then over here, this is the URL of the server that I'm on. And we can see, yeah, there's definitely nothing listening on 8080 here. So we've got a clean slate. Well, if we run another Docker image build, and again, you can just go Docker build if you want. Old habits die hard for some, I know that. We'll tag it the same again. But this time, instead of using dot to use the current working directory as the build context, I'm going to point it to a Git repo. This one here. And away that goes. Exactly the same as before, right? only this time the daemon is pulling the build context across the wire from GitHub. But the process is just the same. And you know what? Sorry, I lied. That's not the last thing. Let's take a look at this output. So sending context to Docker daemon, well, we just talked about that. Then the first instruction, one of 8 actually, from Alpine, pulls the latest Alpine image, and that there is its ID. In fact, yeah, computer, stack each image layer and temporary container as I'm going through the explanation, please.
Acknowledged.
Okay, so we've got the base image at the bottom. Next up, we add the maintainer label. To do this, Docker spins up a new container and it churns out a layer. Once the layer is created, it gets rid of that intermediate container. Poof, gone. Next up, we're installing Node and NPM. I think we see this as doing a bunch of stuff, fetching and installing and all that goodness. But again, it is doing it inside of a temporary container up here. Anyway, it spits out a layer here and it loses the container. After that, we're copying in the app. Looks like maybe we don't need a container for that. Okay, actually I'm not sure about that. But look, we get the layer. Then we're setting the working directory. Again, spits out a layer, shoots the container. Then we run npm install. That runs inside a container, it does all of this. And as usual, spits out a layer and shoots the container. And the same for expose an entry point. Spin up that intermediate container, produce the layers and shoot the containers. That's the process. Now then, only the layers that contain actual data are kept. So even though it looks like these entry point and expose instructions create layers, they really don't, at least not ones that we keep. So if we do this, okay, first up, we can see that only 4 of these layers actually contain any data. Magic. But see these IDs over here? See how they match what we built in the picture here? Commands and all? More magic. But really, we only need these ones. The others are just metadata. So if we inspect the image like this, okay, only 4 real layers. And no, the IDs don't match, annoyingly. Go back to the previous module if you want to know why. But yeah, you know what? That is the greasy, oily detail of building an image. Next up, the exciting world of multi-stage builds. This stuff is the future.